Graham Dodd. I'm a director and Arup fellow at Arup in the materials team. And I'm going to share this short presentation with my colleague Chris Miller, who I'll introduce as we go. And it's really about retrofit materials and the impacts and how we compare options. I said, well, I'm from our materials team. We work with external clients and also with designers and engineers within the firm. And this is what we're aiming to do, really, is help people produce better designs, make sure projects are properly built and well maintained. Those are the overall objectives. And we do that in the materials team by concentrating on making sure people have got good options of materials and manufacturing processes on the table, that they're helped to extract the maximum value and performance from the materials and the processes that they use, and that we achieve overall quality construction, and that as defects and variances occur, as they always do in projects, that those are recovered from and the quality is maintained. And as a materials specialist kind of view of the world, this is one way of mapping out that view. This phrase, making materials work, was a gift of a presentation title that somebody asked me to give a while ago. And I thought, well, actually those three words sum it up. That's our view of what we're about as a team. You can take making to mean, the manufacturing aspects, as you see there on the left of the diagram, or those sort of positive acts of how do you control things, how do you make it do what you want, the design, the specification, and inspection. Right down the middle we've got the material science bit, whether that's the composition and an analysis bit at the top there. The bottom of that diagram, lots of us also look at materials as a package of properties, combinations of mechanical and physical properties, and their other attributes. And then the work, what do we want this material to do? Two aspects to that. On the top rightmost bubble there, we've got the performance, what is it achieving for our building, the value and the impacts. This is an aspect of the material and the process that it's been through. And then finally the conditions under which it has to work, the service conditions, the life cycle, as Patrick talked about, in some cases really long life cycles required. So our view is that to really make materials work, you've got to look at all these aspects and get them all balanced. For retrofit, what we're talking about today, this top right bubble I think is the one we're concentrating on performance. Often we're talking about improving the thermal and energy performance of the building, and then the impacts. What are the environmental impacts that come from using that material, which are the kind of trade-off against the performance. Now, those impacts all emerge at certain steps in the process, in the manufacturing process. Over on the left-hand side of that diagram there, that shows up, we've got our extraction and processing stage. That's where the environmental impacts happen. That's where the embodied energy is involved. That's where the energy is embodied in the process. Again, as you saw Patrick showing, so it's a modern, I think that was a film blowing plant that you showed there. The improvements in the efficiency of how you process a material reduce the embodied impact of that material. But of course, the choice of materials and processes comes from what we specify and how we specify it. So there's a link between our design and specification, the performance and the impacts of building in that way. Just to sort of divide, what do we mean by impact? The visual, architectural or kind of social impact of materials is something that we don't often think about as in engineering terms. It's not something you see on a data sheet, but actually the way that material affects your living environment, what that material means and communicates to you is really important in terms of the quality and the well-being that arises around our buildings. A measurable thing, of course, the carbon emissions, and we're going to talk about carbon payback. That, for me, is the most urgent issue. If we're going to deal with the climate change issues highlighted in the IPCC report SR15, we need to do this fast. So if we're retrofitting buildings, we need to do it in a way that gives us a rapid payback on any extra carbon we might emit in our construction and refurbishment activities. And we have to make these materials healthy, safe, contributing to well-being. Air quality be one aspect of that. Fire safety, of course, uppermost in everybody's mind at the moment, but also these aspects of the perceived quality, what it means in architecture. And finally, making these the way we manufacture buildings and the materials in them, the way we design things to combine materials has to be compatible with circular economy principles, being able to separate natural and synthetic materials at the end of life, so that the technological ones can be recycled and reused in beneficial ways, and the biological ones can return into the soil, into the ecosystem. There are all sorts of retrofit materials. I'm not going to go through those in detail. We're going to illustrate a couple of examples in a moment. Actually, today I noticed that our colleague Chris Joffe is talking specifically about the retrofit challenge for housing, and how would you deal with 14 million buildings in a period of sort of 5 or 6 years to really improve their thermal performance. So I'm going to finish this little section of talk with a speculative idea which came up when I was listening to Chris talk about retrofitting buildings, and this is an art piece from a number of years ago, a knitted sort of representation of a building, and it did make me think, I wonder if you could really knit out of a non-combustible fibre an external sort of woolly external wall insulation. It's quite different to the kind of stuff that Rob was talking about, but we'd have to meet the same challenges. One advantage I thought of this was that it might not be a permanent thing, so that the brickwork or the masonry underneath, which has a heritage value, doesn't necessarily get wrapped up forever. Anyway, that's a speculative idea. Let's move on to how we compare options. And we're going to talk about, well, Chris is going to talk about techniques for comparing those. Carbon payback, which I've mentioned briefly, air quality and how materials influence the indoor air quality, and how we do things to fit into a circular economy way of thinking. So I'd like to introduce Chris Miller.
Hello, thank you for having me here today. I'm sharing the presentation with Graham, and I'm hoping just to take you through three techniques that you might consider for comparing options on building retrofit materials. So the first being carbon payback, and what we mean by that is whenever you build anything, you have to put in some work, you have to invest in some carbon in that thing, and it takes a while for the improved performance to result in the carbon you've invested in the project being worth it. The second thing I'm going to talk about is air quality, and an example of where we've helped develop a strategy for managing air quality inside a project, and how we applied that. And then lastly, I'll talk about circular economy, and one project in particular where we kind of put that in action. So the first one is One Mabledon Place, and if you've walked down the Euston Road, you will have probably seen it. It's I think a 70s block, which was redeveloped a few years ago, and for that particular project, a really big driver was to kind of emphasise the sustainability benefit of refurbishing it rather than stripping it all down or rebuilding it. So we carried out a life cycle assessment for that project, and what you can see on the black line is the kind of the existing building. If you do nothing, this is the kind of profile, the carbon profile you might expect, and it tapers away, assuming you might get some decarbonisation of the grid over time. The yellow line at the top is the RICS kind of industry average data for a building of that type and performance. the blue line is what they ended up with. That was the refurbished building, and the sort of maroon line is if you rebuilt it to the same performance and specification that they ended up with. So it's a really nice graphic for showing that after only 4.5 years, it was worth it to do the refurbishment, and it's quite a quick and short payback for that. And to show you what makes up that carbon. This is it's kind of a typical a graphic which shows you operational versus embodied carbon for this building. So it's about 71% of it was operational carbon, and about 22% was from the materials and products. So that's the kind of the top right pie chart we see there, and then on the bottom we've got a graph which shows us the kind of initial spike of the materials used in the products, and that's obviously quite large, but it's the start of this work. The grey tapering away line is your operational energy over time, and then every sort of 15 or so years there is going to be some further work required to keep it going. You know, replacing carpets, replacing bits of the envelope services and whatnot. So the next one to talk about is television centre on Wood Lane. And this was an indoor air quality project that we worked on recently, and it's the kind of approach on that job. What we mean by indoor air quality is the kind of whenever you buy a new car, you step into the new car and it has a certain smell to it. It has certain volatiles being released from the materials, and they kind of affect the space we're in terms of how we feel in that space, how healthy they are to each of us as individuals living in that space, and so forth. So on that particular project, we helped to establish a baseline. Have a look at what materials might be used, what's typically in them, what emits from those materials, what might be the best in that class, how available those sorts of materials are, and agree a strategy for that project. And then the step 2 was to work out how the specification for that project actually kind of ranked against against the project strategy for controlling indoor air quality, and that led on to how to select any substitutions that might be needed, or an alternative approach. And it was dealing mainly with these sorts of materials you see here. It's paints, internal finishes, the stuff that tends to be the kind of the worst offenders for that. And finally, just to talk about another recent project, is a Lloyd's building, where we managed to really implement the circular economy kind of principles. And they recently they decided that their offices weren't allowing enough light in, and they wanted kind of to have improved views out. So if I jump onto this slide, that image on the right shows what it used to look like, and kind of 3/4 of that unit there has this sparkle glass in it. And so what the desire was to kind of open up that middle section and have clear glass, so you could look out. Previously, only if you were sitting down could you kind of see out around you. So what we did there was took a lot of the existing glass out, and kind of shifted it around. Ended up recycling a lot of glass that couldn't be reused in this project, but actually reusing a lot of the glass that was already there, which is kind of like the ultimate aim, isn't it, for living in a kind of sustainable world. So really nice strategy for that job, and quite unusual. And we wrote quite a lot about this. I'm only touching on that really in this talk, because a year ago one of our colleagues, Graham DeRinker, spent quite a long period, I think, talking about it here again on the strategy for that job. But we wrote a paper with British Glass on rethinking of the life cycle of architectural glass, and you can download that and have a look if you're interested. There's a link there on the bottom. So just to kind of recap for each of those, and Graham's already shown you this slide here, but it all comes back to environmental impacts arise from processes, essentially. So in terms of the carbon payback story, you're reducing the number of processes by refurbishing an existing building, and your performance is way increased by the work, your improvements that you've carried out. So your environmental impact over the long term is lower. For your indoor air quality, you're thinking about the design specification at the start and how to modify that such that your materials perform better from a healthy and well-being point of view. And finally, for the Lloyd's kind of example of the circular economy system, you're increasing the performance and as a result reducing your impact by reusing the glass. So it's kind of all sits within these loops. Thank you very much.